chapter 5 of our finals na. Okay, so we are now on our analytical standards, or because we already know how to deal with our samples or gather data, we'll now be continuing how to have a standard so that all your data are in a very accurate nga, or you will get a accurate nga result. You're having close to accurate or very precise na nga mga result. So you have here first your analytical standards. Okay, standardized or analytical method we use to standard containing your known amount of your analyte. The accuracy of a standardization therefore depends on your quality sang reagent nga ginagamit and also sa glassware mo nga ginagamit kag gina-prepare for your standards. For example, okay, in an acid-base titration, the stoichiometry of your acid-base reaction defines the relationship between the moles of your analyte and also the moles of your titrant. O yan ang ginamin niya ni. Okay, the titrant is the one you have for your known nga reagent. Okay? Then for your analyte is the one you are doing or performing the test to know kung pila ang imo nga need nga titrant for a reaction to occur. Okay? Kay if you know the amount of your titrant, okay, it is proportional to the concentration or sa moles sang imo nga analyte. Okay, in turns, the moles of your titrant is the product of your titrant concentration and the volume of your titrant needed to reach your equivalent nga point. Amo na ang balta nga do ilang nga equilibrium. Okay, the accuracy of your titrometric analysis therefore can be no better than the accuracy to which we know the titrant's concentration. Okay, sa chapter 9, you will be discussing sa aton nga titration or sa aton nga further nga topic. Although hindi na sa chapter 9 gid because gid summarize na namon gid katama. Okay, now for your primary and your secondary nga standards. Okay, we will divide your analytical standards into two categories. You have your primary standards and your secondary nga standards. Okay, what is your primary standard? Okay, it's a reagent for which we can dispense an accurately known amount of your analyte. For example, you are given with a 0.1250 grams of your K2CR2O7 or your that contains 2.249 times 10 raised to 4 moles of your K2CR2O7. Okay, if we place this sample in a 250 ml of your volumetric flask and dilute to the volume, the concentration of the resulting solution is 1.7 times 10 raised to negative 3 moles. Okay? A primary standard, they must have a known stoichiometry. Okay? A known property or your assay, it must be stable during a long-term storage because the difficulty of establishing the degree of your hydration even after drying or a hydrated reagent usually is not a primary nga standard. Okay, na namin yan nga dapat known kung iya nga component. You have here a K2CR2O7. Okay, dapat known man iya nga grams and also ang iya nga moles. Okay? Now, reagents that do not meet this criteria are what you call your secondary nga standards. Okay, the concentration of your secondary standard must be determined relatively to the primary nga standard. Okay, list of your acceptable primary standards are available sa mga formula next pa mga topic. Now, for your secondary standards, the base of or atong nga base, which is your NaOH, is an example of your secondary nga standard kag amo na sang usually nga gina-perform sa laboratory when using or performing your titration. Okay? Basically available NaOH contains impurities of your NaCl or mga N2CO3 or Na2SO4 or your sodium phosphate are readily absorbed by your water or H2O from the atmosphere. To determine the concentration of your NaOH in a solution, it is titrated against a primary standard weak acid, which is your potassium hydrovitaphylate. Okay, or your KH. Okay, K is for your potassium. Hydro, then okay, pH, it is an acid, dilate. Okay, C8H4O4. Now you have other mga reagents dire. Okay, preparing your standards often require your additional reagents that are not primarily standard or secondary standard. Preparing a standard solution, for example, requires a suitable solvent. An additional reagent must be needed to adjust your standards matrix. These solvents are reagents and also potential sources for your additional nga mga analyte sa imo nga sample or sa mga solution which is not accounted for. Okay, to produce a determined error for standardization, if available, reagent grade chemicals conform to the standards set by your American Chemical Society should be used. The label on the bottle or your reagent grade chemical is list or mga listya either the limits for its specific na mga impurities or provide an essay for your impurities. Okay, we can also improve the quality of your reagent grade chemicals by purifying it or by conducting more accurate nga assay for a very specific nga analyte nga kwaon mo lang. Okay, as discussed later sa ating mga next chapter, we can correct the contribution of your sample total from your reagent used in an analysis by including the appropriate blank determination in an analytical nga procedure. Now, let us go sa aton nga preparation sa imong nga standard nga solution. It is often necessary to prepare series of your standard, each with a different concentration of your analyte. We can prepare these standards in two ways. Okay, it is a range contribution between limited into into one or two orders of magnitude. Then each solution is best prepared by transferring a known mass of or ang volume sang pure standard to a volumetric flask kag i-dilute mo into volume. Okay, when working with a larger range of concentration, particularly those extending over more than 3 orders of your magnitude, you have your standards are best prepared by a serial dilution, okay, from a single stop solution. Okay, in a serial dilution, we prepare the most concentrated standard, then dilute a portion of it into preparing the most concentrated nga standard. Next, we dilute a portion of the second standard to prepare a third standard. Continuing this nga process, then you will have more nga different types of standard nga may lain-lain nga dilution. Okay? Since you already know what dilution means, okay, ibig sabihin niya na is the different concentration sang imo nga chemicals. Okay? Is the proceed. Okay, next we dilute mixed portion. Serial dilution must be prepared with extra care because an error in preparing one standard is passed on to succeeding nga standard. Ibig sabihin, kung sala nga volume ginkuha mo sa una, then ginsaylo mo na sa piyak, then gin-dilute mo na siya, okay, it is already a wrong standard or diluted nga standard. Because nagkuha ka da sang sample mo for a next nga dilution, okay, ibig sabihin wrong na nangadaan ang imong nga gina-prepare. That's why you need to prepare it with appropriate nga care. Okay? Then you have here picture of your mga reagent or reagent grade. Okay, you have here your NABR and you have your NaHCO3. Okay, examples of your typical packaging labeling for reagent grade nga chemicals. For level A, okay, provides the manufacturer essay for the reagent for your NABR. Note that your potassium is flagged with an asterisk because its assay exceeds the limit established by your ACS or your American Chemical Society. And for your label B, okay, it does not provide any assays for your impurity but indicates that the reagent meets your ACS specification. Okay, an assay for your reagent for NaHCO3 is provided man. Now let's now proceed sa aton nga two ways of your standardization. You have your single point and your multiple point of your standardization. Okay, the simplest way to determine the value for your standard or for your KA is for sa atong equation diri sa dalong. Okay, it is a single point standardization in which we measures the signal for your standard. Okay, medyo ga double lang entry sa atong words, but it stands for your sample standards containing a known concentration of your analyte. Okay, if you're talking about your analyte, this is your sample. Then you have your C for your concentration and STD for your standard. Okay? Now you have here an equation. Your Ka is equals to your sample standard. Okay, then your concentration nga standard for your analyte. Then, okay, it gives us the value of your Ka. Having determined the value of your Ka, we can calculate the concentration of your analyte in any sample by measuring its signal or your for S sample, and for your calculating for your Ca using your equation. Okay, it is your concentration of your analyte is Cs amp, or for your pKa. Now you have here an equation showing here the curve for your assumed relationship sa imo nga concentration of your analyte, which is ang imong reported, kag sa imo lang nga actual nga ma-perform gid. Okay, you have here your sample and also sa imo nga standard. Okay, they meet sa half delay. This is the point where they interact, or kung if you are doing a serial dilution or kapila mo sa perform, at sa amo ni nga point, they have the same value till here. This is the last nila nga point until nga mag-divert na sila sa ilang patterns. Okay, you have here your S amp and for your S standard. Okay, the preferred approach for standard methods to prepare a series of your standards, each containing your analyte at different concentration. Standard are chosen such as they are the bracket of the expected range for your analyte's concentration. A multiple point standardization naman galing niya, okay, should include at least tatlo gid ka standard nga ginagamit, although more are preferable. Okay, a plot for your series standard versus your concentration standard is known as your calibration curve. Okay, the exact standardization or your calibration relationship is determined by an appropriate curve fitting a log grid. So, pahalusan ako nga mouse. Okay, now you have here your external nga standard. Okay, the most common method for standardization used are for one or more nga external standard. Okay, each contains a known concentration of your analyte. Okay, we call them your external because we prepare your analyze. Okay, analyze the standard separate from your sample. Then you have your multiple external nga standards. Okay, the figure here, the long. Okay, they are prepared with your external or wala na nga. So here sa imo nga external nga multiple external nga standard, you have here a sample of your copper. Okay, concentration of your copper. Okay, this shows your multiple point external standardization. Okay, in your volumetric flask, okay, from your left here is your blank. Ibig sabihin, it is 0. Okay, now for your first, okay, you have a concentration of your copper of 0.05, then 0.1, 0.15, 0.20, this is 0.20, and 0.25. Because nga man, because from left to right, okay, uh, your standards, okay, has the increasing concentration of your copper. Ibig sabihin, kung i-measure mo sila or inbutang mo siya into a linear nga graph like this one, okay, you will see a concentration of your high concentration of your copper and increased concentration sa imong standard win sa imong moles. Okay, now for your hydrogen or sa aton nga what I was talking about is your equilibrium balance. Ibig sabihin is your hydrogen and your iodine gases reacts to form your hydrogen oxide according to following reaction. Okay, if you have hydrogen plus your iodine, they are both in gaseous state, okay, it will form your HI. Okay, ibig sabihin okay, na forward reaction, it will form 2HI. Okay, still in a gaseous state. Pero it can revert back. Okay, your reverse reaction is that your 2HI can also produce the iyang main nga product or iyang main nga composition. Ibig sabihin, pwede siya nga ma-breakdown. Initially, one only the forward reaction, of course, because no HI is present. As soon as some HI has formed, it begins to decompose back into, okay, this will break down, decompose back into H2 and I2 gradually. The rate of the following reaction decreases while the rate of the reverse reaction increases. Eventually, the rate for the combination for H2 and or sa mga hydrogen and also sa mga iodine, okay, to produce your HI becomes equal at the rate of your decomposition of your HI into hydrogen and iodine. Okay, when the rate of the forward and reverse reaction have become equal to one another, the reaction is or sa aton nga is gina-achieve na ang state of balance or ang imo nga chemical equilibrium. Okay, it is the state in the system which the rate for the forward and also sa imo nga reverse is equal to the sa imo nga rate sa imo nga reverse reaction. So you have here kung i-graph mo sila. Okay, for example, okay, your reaction rate and also nga time day. Okay, you have here a chemical that is being formed into a forward reaction. Okay? Then, ang mga chemical nga maging reverse reaction or pabalik siya into a hydrogen and iodine. Okay, ang ginahambalya, imo nga pag mix or pag-combine sa imo nga hydrogen kag imo nga hydrogen kag imo iodine, combining your 2HI or imo hydrogen iodine, okay, will decreases. Then ang imo nga breakdown sang imo nga hydrogen iodine into hydrogen kag ang iodine increases. Okay? As mag-decrease ni, mag-increase ang imo nga breakdown, okay? You will have your equilibrium state. Whereas ang balance nga pag while may mga available nga hydrogen kag iodine, okay, at a sample or sa imong nga analyte, okay, ma-form na siya into 2HI. Okay? Then if 2HI is available, okay, it will break down into H and also H2 and I2. Therefore, as you make okay some nga analyte ga breakdown or compound ga breakdown. Okay, your chemical equilibrium can be attained whether the reaction begins with all reactant and no product. Okay, ibig sabihin, kung all lang kuno reactant, wala pa sang imong product because kung may product nang maubra, it will break down. Okay? Then kung ma-breakdown na siya, okay, damo naman ang imo nga byproduct. Then ma-mix na naman siya. Okay? Kay since damo pa si wala pa product, okay? Ma-breakdown ng bitanan, okay? Ma-combine sila tanan, ma-breakdown. Okay? So on and so forth nga reverse na cycle. Okay? Hasta nga it will reach into an equilibrium state. Okay, or both. The figure below shows the changes in your concentration in your hydrogen and yung mga iodine. Okay, and also your hydrogen iodide for two different reactions. In this reaction, depicted by your graph in your letter A, okay, the reaction begins with only hydrogen and iodine present. There is no HI initially. Okay, as the reaction proceeds towards your equilibrium, okay, the concentration of your H2 gradually decreases, okay, while the concentration of your HI gradually increases. Okay, the curve level, okay, the curve level, the concentration of your substance are always be in constant. In your reaction B, okay, the process begins with only HI, and in this case, the concentration of your HI gradually decreases while the concentration of your H2 and I2 gradually increases. Equilibrium is again reached. Notice that both case, the relative position and also sa equilibrium is the same as shown sa relative concentration sang aton nga product. Okay, the concentration of your HI or your hydrogen iodine and at equilibrium is significantly higher than the concentration of your H2 and I2. This is true whether the reaction begin and all the reactant for your product and also sa position sa imong equilibrium is the property for your particular reversible reaction and does not depend on how equilibrium was achieved. We have here the illustration. Okay, for your letter, for your sa mga letter A and for your letter B. Okay, do you have here sa imo, this is the HI. Okay, then for H plus I nga mixture. Okay, you have here equilibrium between your reactants and your product is achieved regardless to whether the reaction starts with reactant or product only. Okay, so it will have the same nga equilibrium balance. You have here HI this gyapon sa babaw and H2. Then ang level sang ila nga concentration. So it would be the same. So there will be equilibrium constant. Okay? Now, for the concentration of your equilibrium and also the types of your equilibrium, it may be tempting to think that once equilibrium has reached, the reaction stop. Okay? The chemical equilibrium is a dynamic process. The forward and also sa reverse reaction continue to occur even after equilibrium has been reached. However, because the rate of your reaction are always the same, there is no change in the relative concentration sa imo nga reactant and ang imo nga product. Okay, for a reaction that is at equilibrium, the condition or the properties of the system and also sa imong equilibrium are summarized into 4. Okay, the system must be closed, meaning no substance can enter or leave the system. Ibig sabihin ginagamit lang siya back and forth or in a cycle. Number 2, equilibrium is a dynamic process even though we don't necessarily see the reaction sa both forward or making a product kag breaking down into iya nga reactants. And the rate and also sa mga forward and reverse must be equal. And the amount of reactant in the product do not have the to be equal. However, after the equilibrium is attained, the amount of for your reactants and also your product will be constant because it will be balanced. Kindly pause nga the class. Description for your equilibrium is the concept that refers primarily to your equilibrium between your reactants and also for your product in a chemical reaction. Other type of your equilibrium includes your phase equilibrium and also sa imo nga solution nga equilibrium. Okay, a phase equilibrium occurs when the substance is in equilibrium between two states. For example, as stopward nga flask of your water attains equilibrium when the rate of your evaporation is equals to the rate of your condensation. Ano niya tsura? Okay, for an example, ang flask gani naka-sirado. Okay, if you leave it in a room, okay, where the water, okay, evaporates. Okay, makita nyo nga may mga ma-form nga condensation dayon nga mga water sa kilid sang imo nga flask. Ibig sabihin, as your water evaporates, okay, ibig sabihin, galas ang mga water sa dalom, pero makita mo ang mga water ara lang sa kilid sang wall sang imo nga flask. Okay, a solution for equilibrium naman niya, okay, of course, when a solid substance is in a saturated nga solution. At this point, the rate for your dissolution is equal to the rate of recrystallization, although some of these are different type of transformation. Mostly of the rules for regarding sa equilibrium apply to any situation in which the process occurs reversibly. For example naman niya, our next naman gali is your red blood cell transport for your oxygen to the tissue so that they can function. Okay, in the absence for your oxygen, cells cannot carry out biochemical responsibilities. Okay, your oxygen moves to the cells attached to hemoglobin and protein found in your red blood cells. In case for carbon monoxide poisoning, ibig sabihin ginakuha ang carbon, okay, or carbon dioxide. Okay, our CO binds with much more strongly to your hemoglobin, okay, blocking oxygen nga attachment, okay, and lowering the amount of oxygen reaching to your cells. Then, treatment involves the patients breathing pure oxygen to displace the carbon monoxide. Okay, the equilibrium reaction shows below the illustration that shifting to the right with excess oxygen is being added to your system. You have here your hemoglobin as your HB, your CO for your carbon monoxide. Okay, it is in an aqueous solution. Okay, for then being replaced by oxygen, a pure oxygen gas nga state. Okay, and reversibly ma-balance ang imo nga hemoglobin that will be taking your oxygen na instead of your carbon dioxide ipagwaya nga as gas na hindi na nga magmix sa into aqueous. Aqueous solution is a mixture of your gaseous and liquid. So it is a aqueous na solution. Then you have your equilibrium constant. Okay, considering your hypotheoretical hindi ko nagkuha sang Arman, hypothetical reversible reaction in which reactant for your A and also B, okay, to form a product that is your C and also D. This equilibrium can be shown below, where the lower case represents the coefficient of substances. You have your A, you have your coefficient nga A and coefficient nga B, and also sa C mo kag sa D. Okay, you have here the reactants, your A and B, and your product, your C and D. Okay, as we establish the rates for your forward, okay, which is forming your product, and reverse reaction, which is the breaking down, at the same time, it's what you call your equilibrium. And the concentration of all your substance are in constant. Since this is the case, it stands a reason as such a ratio that your concentration for any given reaction at equilibrium maintains a constant nga value. The equilibrium constant or key EQ is the ratio of a mathematical product and also sa iya nga product of your products of a reaction to a mathematical product of a concentration of reaction for of the kapila liwat-liwat ga error aton nga sa module sa each concentration is raised to the power of its coefficient in the balance chemical equation. For the general reaction above, the equilibrium constant expressed sa aton nga formula for your equilibrium constant is equal to the this is ang C kag D, that is your product, and ilang coefficient or kung ano ilang value, and for your A and B as your reactants. Okay, then also ilang coefficient. The concentration of each substances indicates by a square bracket such as your formula and are being measured in molarity unit. What is the molarity nga unit? It is in moles per liter. The value for equilibrium constant for any reaction is only determined by experiment. As detailed in sa aton nga above section, the position for equilibrium for a given reaction does not depend on the starting concentration or also man siya nga value of equilibrium constant because it is a true constant. It does, however, depend on the temperature of each reaction. This is because equilibrium is defined as a condition resulting to the rates of your forward and reverse reactions being equal. If the temperature galing mag-change, okay, the corresponding change in those reaction rate will alter your equilibrium constant. For any reaction in which your equilibrium constant is given, the temperature should be specified. Ibig sabihin, all throughout the process, it must be the same. When your equilibrium constant is greater than 1, the numerator is greater than your denominator. So the products are being favored, meaning the concentration of its product are greater than of your reactants. Okay, pero kung imo naman yang equilibrium constant is less than 1, ibig sabihin, ang imo nga reactants or ang imo sa dalom, okay, are being favored or mas dako ang ilang value. Okay, is larger than your numerator sa imo nga products. Then, if your K or imong equilibrium constant is equal to 1, ibig sabihin na the concentration of your reactant and product are approximately equal. For example, give ta lang for example, if you have 2 and 3, then you have here 3 and 2. Ibig sabihin, they will be a total of 6 over 6. It is an equal nga or equilibrium constant nga equal. Then for example, if it is 4 and 1, then dili 5 and 1, therefore it is 4 divided by 5. Sabihin, your product, your reactant is greater, therefore it is being less than 1. Then if it is 6, di ang imong total it is be 3, ang imong C, ang imong D is 2, then ang imong A is 1, and then ang imong B is 2. Therefore it is pila? 6 divided by 2, it is 3. If it is greater than 1, therefore ang imong product is being favored. That's why. Now, for your reactant coefficient, okay, the reactant coefficient or your Q is used when questioning if the equilibrium or if we are at your equilibrium na. The calculation for your Q is exactly the same for your constant or for your K. But we only use K when we know we are at your equilibrium na. Comparing your quotient, okay, to your constant allows the direction for your reaction to be predicted. Okay, for example, if your quotient is pareha sa value sa imong K equilibrium, okay, then if your K is ang kung amo nga sign, okay, it is less than, okay, less than your K, reaction proceeds to the right to form more product and decrease the amount so that the value of uh, your Q or your quotient is the same as your K. So, magiging balance siya or magiging equal. Now, if your quotient is greater than your K, okay, or your sa mga constant, ibig sabihin na, okay, mag-decrease ang amount sang imo nga, okay, the K or reaction is to form more reactants and decrease the amount of product para mag-decrease ang imo nga quotient. Okay, so that would be all sa ato na nga topic regarding sa atong equilibrium balance. So we only have around 3 more chapters to go and we will end this semester. So that will be all, class. See you next time and God bless you always.